Hello, in this video we're going to talk about standard reduction potential and standard hydrogen electrode SHE. Before we're going to proceed, we need to know that the electrode is defined as the potential difference produced between the electrode and the solution in a half cell. It is also a measure of the half cell to be able to attract electrons. Therefore, the units that we'll be using for electrochemistry will be in volts. Another thing that we need to know is standard electrode potential. So this is the thing that we want to focus on in this video. Another name for standard electrode potential, it is also known as the standard reduction potential, and it will be abbreviated as SRP. And the symbol for SRP is also will be written in that form. When you have E stands for the electrode, and the symbol over there, 0, stands for standard. The standard electrode potential or standard reduction potential is defined as it is a measure of the half cell to attract electrons at the temperature of 25 degrees Celsius and 1 atmospheric pressure for gases, and the concentration of the electrolyte should be 1.0 molar. So if we have a different temperature or a different pressure or even a different concentration of electrolytes, that situation is no longer going to be at the standard electrode potential situation. It will be a different situation, and we're going to look that situation in another video. In here, what I'm showing you now is the list of standard reduction potential values for all of the reduction process that we can have. So this is a typical table that you can have it in the textbooks or on the internet. So the things you need to know about the E0 values or the SRP values. Number one, if you compare with the enthalpy, okay, point number one, if you want to compare that with the enthalpy right over here, so if you have the enthalpy, you have a reaction. When you reverse this reaction from C plus O2 to make CO2, becoming CO2 to make C plus O2, you can see that the delta H value or the enthalpy value will be changing sign when you reverse that. So when you look at the reaction down here, this one has the E0 value. So what happened if you're going to reverse? If we're going to reverse that reaction, let's say you're going to have it Au, solid, gold aqueous plus 3 moles of electron. So what happens to that value now? You will get E0 equals to negative 1.50 volts. Okay, so just like the enthalpy, the standard reduction potential value, if you reverse the reaction, the sign will change as well, as what I have noted right here. The signs of E0 changes when the reaction is reversed. So in that case, it will be the same as the enthalpy of which you have learned in the thermochemistry chapter. But in point 2, what happens if you times with a certain number? Let's say you have this reaction on top, and this one has the enthalpy value of negative 394 kilojoule per mole. So if I am going to multiply the whole thing over here with 2, the delta H will also going to be multiplied by the same number, as you can see right there. It will be different if you compare with your standard reduction potential. So let's say if we're going to times by 2. The only thing that you're going to times with 2 is the reaction equation, but not the E naught value. Okay, so if you times 2, you're only going to times 2 here, but that one will be remains. So you'll have 2 Au3 plus, golds 3 plus, plus electron, and you have 2 gold solid, but the E naught value will be the same. Okay, so you will not going to change the value no matter how much the number you're going to multiply it over here. The only thing you're going to be multiplied by 2 is this. So that one should be 6 times by 2. Then you get 6 electrons. Okay. Moving on to point number 3. So this one is slightly more complicated to be understood. But when you look at the table of which I have in here, you have the SRP value for all of the reduction process here. Okay, so all of these are reduction process. Why is it reduction process? Because it's very clear that it is a gaining of electrons. Look at all of the electrons. They are on the reactant side. So this is gaining of electrons. So gaining of electrons will be a reduction. Okay, so all of these are reduction process, and the number you have there, okay, all of these numbers right here, these are the SRP values or E naught values. Okay, so what I want to emphasize now is when you have more negative SRP value, that will indicate greater tendency for the half cell to become the anode half cell. So let's say if you want to build half cell between nickel and tin over here. Okay, you have negative 0.25, negative 0.14. So let's say we're gonna try to build this half cell, and you want to connect with, let's say, tin just right above it, right there. So between that two, between this two over here, which one will be the anode? You have to look at the SRP value. Remember, these are all the SRP values. Look at the SRP value. Between the two of them, which one is more negative? The one that is more negative will be nickel. So we can say that this one will be the anode, and this is going to be the cathode. Why? Because the value that you have in here, okay, for the nickel reduction process is more negative in value for the SRP if you compare with tin. Okay, so if you want to compare with, let's say this time, I want to build half cell between this, okay, and I'm going to use green this time, and this one. So which one is going to be the anode? The one that will become the anode is the one with more negative SRP value. So between plus 0.15 and plus 0.13. Plus 0.13 is more electronegative value if you compare with plus 0.15. So according to what we have learned in here, more negative SRP value indicates greater tendency for a half cell to become the anode. And if you want to build the galvanic cell between this half cell, the one in yellow, and the half cell, the one in green over here. So the one that will become anode is this. This one will become your anode, and this one will become your cathode. Okay, because you have more negative value over here if you compare with plus 0.15. So let's say if we want to try another one. So let's say if I want to build between tin over here and between your hydrogen. Okay, so which one of these two half cells will be the anode? The answer will be this. So you're gonna have this to become the anode, and this one will become the cathode. Okay, because the SRP value for the one I have highlighted in yellow is more negative if you compare with the SRP value of your hydrogen over here. Remember, again, I would like to emphasize the value that you have there is the SRP value, or E naught cell. So it's very important for you to be able to know what is the purpose of having the knowledge of which one is going to be more negative in the value of SRP and which one is going to be more positive, because from there you would be able to determine which one is going to be the anode and which one is going to be the cathode. I hope that one should be clear for the standard reduction potential values. Okay, again, the more negative standard reduction potential value, E naught cell, indicates the tendency, greater tendency for the half cells, all of these are half cells, to become the anode half cell. So another point, number 3, continuation from there, if we have more negative SRP value, that also indicates the increasing strength as reducing agent. So when you look at all the values over here, so you have going down, you will have greater and greater tendency or increasing strength of becoming reducing agents. And then if you have more positive SRP value, if you go up, it will indicate increasing strength as oxidizing agents. It's just the opposite of what we have in here. So if I want to summarize what we have done in here and in there in a single slide, we can say that when the reducing agent strength is greater, okay, the possibility to become the anodes or to be oxidized will be greater, okay? Because reducing agents, if you are the reducing agent, you will get oxidized at the anode. And if the oxidizing agent strength is getting greater or getting stronger, the possibility to become cathode will also going to increase. Meaning to say, if you are the oxidizing agent on the galvanic cell, remember in the galvanic cell, you only have 2 half cells. So if you are the oxidizing agent, you will be reduced at the cathode. So oxidizing agent will be at the cathode because it will be reduced, and reducing agent will be at the anode because it will be the one that getting oxidized. So you have to remember that concept. Now, the question is, how can all the scientists get all the values over here? We have this very comprehensive table compiling all the E naught values for all of the half cells. And how did the scientists do that? The answer is, what they use is the standard hydrogen electrode, SHE. So the standard hydrogen electrode over here is used as standard reference electrodes to determine the SRP of other electrodes. If you go back to this slide, you can see that the one in red there, that is the standard hydrogen electrode half cell, and it has the E0 value of 0. So we know that the standard hydrogen electrodes, the SRP value will be equals to 0. And because of that, the scientists, the chemists, they're going to use this electrode. So this is how you're going to draw the electrodes of the SHE. So they're going to use this, and they're going to connect this with other half cell, and from there, they would be able to determine the standard reduction potential of other electrons, okay? If you read the one in black here, it will be made up of platinum electrode. So you have platinum electrode over here, and then you're gonna pump in hydrogen gas at 1 atmospheric pressure at that temperature, and you're gonna immerse this whole thing inside the H plus aqueous solution at 1 molar. Okay, so this is very important. You need to know how to draw this, because in exams, they might gonna ask you to draw the galvanic cell involving SHE. So this is how you're gonna draw it in the complete diagram. We have the SHE on the anode, and then when you connect that with a cathode half cell, you're gonna start to see the electrons to flow from anode to cathode. Okay, so it's still going to be using the same concept. The electron will be flowing from anode to cathode. Why? Because the anode will be more electronegative if you compare with the cathode. So that's why the electrode will flow from the one that is more electronegative towards the one that is less electronegative. Okay, so if you have done all of this, when you look at the area over here, you can see that the E0 cell value is 0.34 volts. Therefore, that is going to be the reference point that we're going to use to find out what is the half cell or the E0 cell for your copper. So the cell notation, if you want to write this cell notation, we have done this before. So this is how you're going to write it for the standard hydrogen electrode, all the setups over here. Okay, so that's all for this video. I hope that will be helpful for you.